Okay, welcome everyone. Today we have a bit of a lighter topic. I wasn't expecting a large attendance today, but I think that there's been some work that's been happening lately on AR64 that kind of motivated today's topic. I wanted to talk about the commenting up the out-of-line instruction generation code that exists in the code generators. For those of you that are not familiar with what out-of-line instructions are, they're basically a means by which a code generator can inject its own control flow in the normal instruction stream. And the idea about this control flow is that it's localized control flow in the sense that it's intended to be used within a single basic block. It's not intended to branch to another block or anything like that. You're supposed to go out, do some work, and potentially come back if necessary, without changing the control flow graph. So this is actually used, and it's actually useful in a number of different places throughout the different code generators. So for example, handling unresolved data references, arithmetic instruction flows, you need to fix up a little bit of code, that kind of thing. So this is implemented on all architectures. All code generators support this. On x86, it's actually called outlined instructions. The initial design many years ago began on x86, and then all the other architectures followed. The other architectures actually are following sort of a different class structure than x86. At one point in the past, a commenting effort was similar to what I'm proposing here, but a commenting effort was attempted where all of those implementations are derived from a common out-of-line code section base class. The only real issue with that, though, is that there isn't really very much code that's shared between those different implementations. It's really just sort of the very top-level API that's shared, and everything else is pretty much repeated across the different code generators. So when you actually look at the functionality that this code provides, it really is pretty much identical across the different code generators, and it's really just sort of the subtle nuances about each code generator which really makes it, which is really the reason why we have to have duplicated implementations of it. So what this sort of high-level epic will address is really an effort to begin to common up those implementations and to share much more functional logic than is currently being shared. And when we're looking at the kinds of features to roll into this, actually this is another problem in the sense that because we have all these independent implementations, some architectures do more and some do less than others. So I would say, for example, that I think that Z and x86 have probably got the richest implementations. I don't think they are actually implementing exactly what the other does either. So I think that there is an opportunity to kind of go through those implementations and understand what the best features are. I think Power and ARM are still very much a minimalist implementation, and in fact, if you look at the ARM code generator, out-of-line instructions in general are used fairly sparingly, and I think that's more. It's not because the opportunities aren't there. I think it's just that it's not something that was ever really considered to be used in that code generator, and I think that needs to change. And certainly for AR64, as we go forward with that, we need to keep that in mind as that gets designed. So looking at those architectures, Z and X, I think that there's a number of different features that I think would be useful to have in a common out-of-line instructions implementation. The first is, really the ability to handle an arbitrary stream of instructions and having those instructions map back to a particular node. And the way that that's sort of implemented right now is that, well, actually, the very first implementation of the out-of-line code sections really just were intended to handle call nodes. And if you look at the implementations, there's a lot of terminology being used there that really sort of points to the fact that it's intended to be used for call nodes. Some of that is actually is no longer the case, so that needs to potentially change. But the fact that these instructions can sort of map back to a particular node means that they can now also participate in sort of metadata generation, and you can kind of keep them. You can keep the information that gets generated about those instructions. You can actually generate metadata for it, and other parts of the VM can potentially find that information and attribute it to those instructions if necessary. So really being able to lay out whatever arbitrary sequence of instructions you want, I think, is important.
Just a quick question there on that topic.
Yep.
Is it actually possible to lay out an arbitrary set of instructions? Because I remember doing this a couple of years back where I wanted to change some snippet-based code to use out-of-line code gen, and I found that anything outside of a simple diamond was uncharted territory, basically.
Well, I think I think the answer should be yes, but perhaps at the moment that's not the case. That we don't have the right kind of infrastructure in place to allow that. I think aspirationally, and I'll get to that in a second here, but aspirationally, I think that we want to be able to replace our snippets, our handcrafted snippets, with some kind of infrastructure like this, but. I mean, I think it maybe depends on the architecture that you're on too. Like, presumably, you were doing this on PowerPC, and you're having some issues with it.
It was PowerPC, and if I remember correctly, snippets I wanted to replace had either multiple branches into the snippet, and or multiple branches out and back to mainline code. So.
Okay. That is getting. So the way that things are currently architected, I think, across the board is that the expectation is that there is a single entry point to the out-of-line instructions and a single exit point.
Right.
And the reason for that is just the way that when we're actually doing register assignment, it needs to be able to capture the register states at a couple of different points and restore it at a certain point as well. So I think that having more involved control flow like that is going to take some thinking. But I think that's if that's really a worthwhile thing, then I think that's something we need to.
So the snippet did this because what I could tell, it was actually worthwhile to do this. There was efficiency to be had in entering the snippet below the entry point, and there was efficiency to be had in leaving the snippet early, and expressing those sorts of things in out-of-line was essentially impossible for the reason you said, unless I went out of my way and made sure that, for example, if I was branching from multiple places into the snippet, making sure that nothing could happen, the register allocator couldn't do anything between the branches. That way, the snapshot at one of the branches would be essentially equivalent to the other branch. And
we would, I mean, we'd have to start teaching the local register assigner about when it's taking its snapshots and now it needs to understand the control flow within the out-of-line code, which is getting fairly complicated. Do you remember what snippet it actually was? What was the functional?
I think it was an open or IBM Java monitor enter and monitor exit, I think, possibly. And they had, there were multiple paths. I don't remember the exact details, but you wanted to jump to the snippet to do something quick, and if you managed to do it, you wanted to jump back out. Otherwise, you wanted to continue to do more things, and then you could possibly jump out early. And basically, it was not a diamond, and if I remember correctly, I think I left it as a snippet.
Okay.
Or possibly replaced it with out-of-line code gen that wasn't as good, but we just bit the bullet and did it. I don't remember the exact details.
Okay. Do you know if there are other similarly complex snippets in?
Definitely. In my experience using out-of-line code gen, I want multiple branches into a snippet.
Okay.
Because usually you want to test something and decide I have to go out of line, and then let's say you can continue, you want to keep going, you have to test something else, and you want to go out of line again. So multiple branches into a snippet is probably one of the more common control flow patterns you'll see outside of the diamond.
Okay.
The other variations, I don't know. I don't remember having to use them.
Okay. The use cases that I'm familiar with on x86 and on even on Z for outline instructions, actually most of them revolve around you want to be able to do some kind of a call, but that call is specialized as some kind of linkage, and you don't want to have to encode that by hand in the snippet. So you basically just cook up a fake node with a call node. You cook up a fake call node, and you evaluate it in the snippet or in the out-of-line instruction sequence. And so
I think we
it's fairly
do that
simple.
as well, on Unpack as well.
Yeah. Okay. Okay, that's a good piece of feedback there. We have to think about. I mentioned the creation of metadata and the ability to do that over arbitrary instruction sequences. Right now, that is somewhat tied to, certainly in the case of Java, it's tied to the ability to map those instructions back to a particular node, but you also have to make sure that exception ranges in the metadata are covering the right ranges of instructions in case that they do throw an exception of some sort. One thing I've got here that I thought looked, it actually looks kind of like quite clever, is the some work that Victor's done recently with actually part of the previous one. We're actually extending it to generate more metadata, but he also added the sort of an RAII feature where it replaces the actual manual switching of the instruction stream, and it really just uses sort of a scope-based, it just sort of happens automatically based on the lifetime of the outlined instructions object. So it looks a little bit cleaner doing it that way. So that might be something that can be replicated across. So that I know Philip looked at that for Z, and he was interested in doing it there as well.
Speaking of Z, I just remembered they do something where they have recursive out-of-line code gen, so they'll go out of line to generate some code, and then that code will decide it wants to generate something out of line.
Mm-hmm. So nested.
Whether that's good or bad, I don't know, but that is something that they do. From what I remember, the nested out-of-line sequence doesn't actually do much as far as changing register allocation. So I think it's one or two instructions that may or may not even have any register dependency, so they don't change the register straight. So that just might be a special case that they got working, but it wouldn't have worked on Power because the register snapshot, I think there was only one. So you could really only have one snapshot active at a time, so you wouldn't be able to do that. But
x86 is certainly being bitten by the internal control flow regions where they get nested, and there's only one snapshot at the outer level, and then the register assignment is all screwed up inside. It'd be really nice if, in re-architecting it, we could get some kind of a cert or something to make it obvious when somebody has generated a sequence. Like, those sequences often work functionally just by fluke of the register assigner, but if there was a way to make the code generator actually violently assert when it's put into doing one of these strange things.
I think it counts the depth, if I'm not mistaken. It's a while since I've looked at that code, but when you create a a label for internal control flow, doesn't it increment some depth counter?
I never found one, but that doesn't mean it doesn't exist. I'm not.
It's been a while since it may have existed at one point, and maybe that's what I'm thinking of.
There is a count. I don't know that it counts depth, at least not on power.
Okay.
But anyway, I guess I'm just suggesting that if we could maybe just try and structure things to have some more asserts and things about the invariance that we expect for these, like, if it's single entry, let's make sure there's an assert about that, and, we could, even if it's just scanning the instructions, the instructions once they've been generated to look for branches into the middle of it or something, right? Mm-hmm. You may not enable it by default all the time, but it would be so helpful to be able to force the compiler to verify the invariance that we're expecting to hold.
Mm-hmm. Okay. Good.
Paranoid code gen, I guess we could call it, right?
Yeah.
It didn't really make sense to me why you would want nested out-of-line code, because once you go out of line, what does it mean to go out of line from there? The out-of-line code section is already outside of normal control flow, so it's already going to end up somewhere at the bottom of the method in cold code. What does it mean to go out of line again? Why don't you? But from talking to the Z guys, I think it was more you wanted to be able to reuse the same code in an out-of-line context as well as an in-line context. So you wanted the code to not care whether it was being invoked out of line because it wants to generate something out of line. So you could call the same code from an inline sequence, and it would generate something out of line. And then you could also call it from an out-of-line sequence, and it would generate, and it wouldn't have to care, basically. Mm-hmm. So I think that was the motivation, if I remember, which seems reasonable, but...
Okay, I mean, I think that with the right kind of design, I think that you can support that sort of thing. I mean, whether or not, I guess we should have some ideas of whether or not that's something we really want to do, but if it's not hard to support, then that's why we couldn't do that. Okay, so speaking of the snapshots, the way that it works right now is that there isn't really even though every architecture actually goes ahead and takes the snapshot and restores the snapshot, there isn't really sort of a similar API, and the actual implementation of it is different on every architecture. I think that managing perhaps a stack of these snapshots is possible. Even the logic within that, the actual process of taking the snapshot and restoring the snapshot, I think can be, perhaps commented into the machine class in some way that it can be shared. The big challenge, I think, with all that is, and I get to that in a little bit later, but one of the bigger challenges is really, and one of the reasons why things are different across all the different architectures is because of the way that we tend to use the real register enumerations, right? So we're looking for spilled registers, we're looking for no regs, we're looking for certain registers, and we're iterating over the range of known registers. Those enums typically are tied to a specific code generator, and because of that, every code generator ends up with its own implementation of it. There is some specialty code that some architectures have to take care of, like, for example, on Z, I think they have to care about, they have to take a bigger snapshot, like they need to take the HP, the high word registers. There might be some condition registers as well, that sort of thing. So there needs to be some kind of architecture specialization, but I still think that the bulk of it could still, or a lot of it, hopefully can still be commented on. The management of the out-of-line instruction list, I think, is also something that should be shared. Again, everybody implements it in their own code generator. How to iterate over the different sections, how do you swap the instruction streams, that's all sort of independent of, or it's all written exclusively in the code generator as well. It shouldn't have to be that way. And then the other maybe sort of final feature that I just thought of was addressing what Eunice was saying initially, was just having something that's actually going to be replacing the handcrafted snippets that are there right now. I think is really sort of the ultimate goal of a lot of this, just so that we can deprecate that technology. I mean, those snippets were generated at a time, like the snippets were around from the very beginning of the Testarossa architecture, where it wasn't really possible to do the kinds of things that we're doing with this technology right now. But that time is perhaps long past, and it's probably worth deprecating those if we can. Any other sort of requirements that you think would be useful for any use cases of this instruction stream that you wished you had in the past that you, like, I know other than what you just mentioned, that you can think of anything. Okay. Yeah. So we can just add it to the issue later. It's a pretty good starting point here. Okay, so some challenges with this, with at least coming up with a common design, and I think that it's sort of encroaching on something that's there are a number of different parts of these code generators that are kind of all intertwined with each other, and I think that I mentioned here that it's going to have a bit of a viral effect. And I think that one of the things that it's going to run into right away is the fact that the register dependency mechanism, so the way that you actually, the mechanism that we have for specifying a mapping between virtual registers and real registers on a per instruction basis, at the moment that is also implemented per code generator as well. And I think a big part of the reason for that is also because of these register enums, right? And the fact that it's mapping a virtual register to a real register that's only known to a particular architecture. So we've had, over the years, when this was still a closed source project, there have been a couple of attempts at re-architecting the register dependency mechanism. It didn't, I think it didn't succeed for for technical reasons. I think it really just didn't succeed for priority reasons. It just wasn't worth the effort to go about, because there are a lot of places in the code that actually do use register dependencies. It wasn't worth the effort to go about changing all that at that time, but that doesn't necessarily mean that it shouldn't be done. We've had, almost 20 years of experience using the current mechanism, so there are undoubtedly lots of, we have a lot of experience with them right now. What works, what doesn't work, what are the features we want, what are the features we don't want, that kind of thing. So I think that there's a place for re-architecting those in the future. I know that Philip has a few ideas on that as well. So what I think will end up happening there is that we'll have to create a new issue in Epic for that, and we can have others weigh in on perhaps shaping the design for that and see how that goes forward.
Yeah, so if we could start that discussion, because one of the things that Victor and I are going to be looking at is that there's a slew of new AVX instructions on x86 that have re-register form. Mm-hmm. And the current x86 register assignment, the register assigner itself can't cope with 3 register forms. Mm-hmm. And even how we're going to put them in is a bit of an unknown, but we need to add that capability first for the GPRs, but eventually we are also going to need to add the support for the K flag registers on the new AVX vector instructions. So for the conditional registers on those for the advanced AVX encodings. So it's not an immediate priority, but it is looming on the list of things the x86 code gen is going to need to do to stay competitive sooner rather than later. So.
Okay. And in the worst case, you would just hack the register dependency mechanism that's there on x86 right now. And
so Victor has hacked it, and it does. You can make it do things. The thing we found just with our initial experiments with that was just that some of the 3-register forms have a slightly higher execution cost and things like that. And some of the savings of the 3-register forms are to allow the greater freedom in the register assignment, and that's something that the code generator just isn't capable of exploiting at the moment. So it's a strategic thing that needs to be done in that code generator over the next little while.
Okay. So I think one of the things that's going to feed into that is what I mentioned earlier about the fact that the reason that we have a lot of this sort of unique implementations is because of the real register enums, right? So this is basically describing in an enum the registers that are available on a particular architecture, and they're typically like PowerPC specific or Z specific or x86 specific, and really, in some cases, the only difference between the various architectures in terms of the implementation is just those enums and how do you iterate over those registers in that enum, and that's it. There's a lot of very similar logic that should be shared. So I think that we need to find a way of providing a generic form of those. Basically taking the enum out of it and providing a generic form of that so that we can share a lot more logic. We also need to be able to share things like there are sort of these special enum flags, like is it a spilled register? Is it a no reg? Is it a things like that should be shared, because those are also duplicated across the different architectures as well. So I think we need to think about how to do that, and that'll probably feed into the regdep design, and it'll probably feed into this design as well. So
one thing I'd like to mention, just remembering a very old conversation or meeting we had on this, is that a lot of times you'll find code that just a lot of code dedicated to just figuring out how many dependencies you need. So you'll look at certain evaluators, and half the code will be trying to figure out how many, arriving at a number of dependencies that you need, checking this, that, and the other to come out with a number, and then the code will be repeated to actually generate the instructions that use it. 50% of the evaluator is code dedicated to coming up with the number 10 or something, because that's the way it's written. And the other approach was just allocate the biggest register dependency conditions that you can. I think all of the code generators or machines had max number of registers or something like that, and you could do that as well. But I've seen both.
Yeah, there's certainly a trade-off between the logic, and so the initial, and I think it's still the same design of these register dependencies, was to be very, very tight on the memory usage, right? And so you have to tell it exactly how many, and it actually goes and expands the, there's a struct that it uses, and it just allocates at the end of that, however, exactly how much memory you or how many dependencies you say you're going to need. But it really makes it inconvenient. It was fine for very simple cases, but it really makes it complicated when you have some of the more complicated control flow of that to count the number of dependencies you need and all the different conditions. So it may make more sense if we relax that a little bit and really just allow you to add whatever you want. Of course, we have to be able to control the memory, but control the consumption of it. But I think that there are ways of doing that. But I think it would simplify a lot of the code for sure.
I don't know if this is outside the scope, but one of the things that caused some consternation for a while on x86, and is probably still suboptimal, is the handling of condition codes off of some of the instructions. So, like, a great example would be like you have some trees or something where you do an add, and then the add is going to be compared against 0, and then you're going to branch conditional, right? Now, on x86, the add will set the 0 flag if it's 0. Mm-hmm. So you don't actually have to generate the compare because, well, you know. And you can then just branch conditional directly on the add. And at the moment, I believe that's a backwards walk to find the last instruction that set the condition flag, and then is it the instruction that I wanted? And if it is, then I can skip this thing and blah, 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 blah. Mm-hmm. That always struck me as exceedingly clunky. I don't know if there's a better way of doing it, but it's one of those things that always made me cringe when I had to go and add another case of patterns and flags that to it to get rid of redundant tests and redundant compares and things, because there was an operation just 4 instructions before or whatever that had set the flag based on exactly the thing that I needed.
Yeah, and you also had to manage the insertion of instructions that potentially would mess up your flags. Like if you had already calculated, I've got a test, and I'm going to put that whatever, and then because I remember we've had bugs like that in the past. Yeah. For that.
It may be outside the scope of this particular discussion, but I just thought I'd throw it out there as another one of those things that was very surprising when I found it and rather annoying.
Okay. Okay. So in terms of I think those are the biggest challenges that are sort of facing this right now. And I think that if we can actually genericize some of the register concepts, then I think that it's going to make this effort a lot easier. I'm also thinking that at some point in the distant future, there are some opportunities of actually sharing some of the register assignment logic between the different architectures. And one of the things we need to do to get there even is to actually have a more genericized notion of what the register names are. So this is going to be a step in that direction as well. But one thing at a time. So anyway, I wanted to propose a re-architecting of the out-of-line instruction mechanism. I've got an issue open for that. Certainly invite any feedback, any comments, any suggestions, any use cases that you've had in the past, by all means.
Yeah. Would you mind adding Victor on that just so that he's aware of it?
Yep.
Because I think he may have some useful contributions to that discussion. He's got a lot of ideas about how things might be better.
Okay. Yep. Right. I'm going to throw this out as a help wanted kind of task. It is a bigger piece of work for sure, but it's important nonetheless. Mm-hmm. Okay. That's the only topic that I had for today. Any other discussion you want to have on that? No?
No? On that particular design, no.
No? Okay. All right. Okay. Well, if there's no other discussion on that, then I will close the call then, and we'll talk again in a couple of weeks. Thanks, everyone.